Hey everybody, this is chapter 7, section 5. We're just kind of expanding a little bit with triangles, and then we're going to be kind of using some transversal rules here to kind of wrap up proportions. Okay, so typically, when I do videos, I go pretty quickly, so try to, with your notes, try to hit pause if you need to get caught up, and then hit play to get when you're ready to go again. And make sure too that you're checking in with me, get any help if you're watching the video and you're not really sure about some of the stuff that we're doing. Okay, you have two theorems up here at the top. One's called the side splitter theorem, and then we have a converse of that. So they're the same thing, just saying it backwards basically. So in 7.4, the side splitter theorem, if a line is parallel to one side of a triangle and intersects the other two sides, and it divides the sides proportionally. Okay, so if you take a look at this really quick, if I can move my thing here, there we go. What this is saying, using the triangle we have over here, hopefully you can see the whole thing, is that you're able to then say, because these two lines are parallel, that you could say that, and you could set up your proportion any way you want. So I'm going to start with QT, and I'm going to say that it's proportional to the other segment of its side, so TR. All right, and then I'm able to set that equal to the other side of the triangle. So I'll start with SU on top, and its other segment is UR or RU. Okay, so that's basically what that theorem is saying. Okay, the converse of that, so the one below it, just says if you're able to prove that this is true. So typically you take some lengths and plug it in there to see if they either reduce down to the same scale factor, or they if you do your cross products and the cross products come out to be the same, then you could say that these two lines are parallel. Okay, so just saying it backwards. All right, okay, and it's kind of what we're doing, just it's with parallel lines then that are able to come up with another rule, and you're able to say it. Okay, so taking that rule, using that these two lines are parallel, I could take the segment CD, which is 4, put it over DV, which is 8, and that really doesn't make sense to me because they don't look like 4 and 8, but that's what they gave me. One rule in math too, things aren't always drawn to scale, so just take it for what it is. I'm going to call CE then, since I went 4 on top, I'm going to call this X, since that's what they want me to find. It's just easier for me to write, and I'm going to put it over 12. Okay, so since these are parallel, I can set up that proportion. I could do my cross products, and that gets me this, and I can solve that for X. Okay, so I can divide both sides by 8, and I get X is 6. Okay, and if you plug that in, that should come out to be the same. All right. On these, they're asking, or this next example, they're asking, are these two lines going to be parallel? So they give me the measurements. I got to plug those in and see if I get either the same scale factor, or I do my cross products and I get something different. Okay, so on this one, you can set this up any way you want. I'm going to just start here, and I'm going to take 21 and put it over its other segment for that particular side. Okay, I'm going to set up my other proportion, kind of staying, I'll call this corresponding with 21. So they both have to be on top, and its other segment's that. Okay, so you can do your cross products here if you want. That's one way to kind of see. If I cross product there and cross product here, I hope that I would get the same number. If I don't, then they're not parallel. So that's one way you could do it. I think a little bit easier way, just try to reduce these. So for this particular ratio, 21 over 56, 7 goes into both the top and the bottom, and I get this. For this particular ratio, I believe 16 goes actually into both of them, so I get 1 over 3. And those two scale factors or ratios are not equal, so these are not parallel. So really my answer is no, they're not parallel. Okay? All right, so that's just taking the converse and using that rule and just trying to prove it or not. Okay. On this one, I could tell that these two lines are parallel because these two angles are the same. They're 90, but they're same. So, basically I have a transversal here now. Those are corresponding angles. If the corresponding angles are equal, then I can say lines are parallel. So hopefully, you remember that back from chapter 5, I believe it was, or chapter 4. Okay. So what I'm going to do now is I'm going to take this x and I'm going to put it over 9. Okay, this 9. So that's taking the two segments of that side. And I'm going to take this 9 now and put it on top since I've kind of got those together, right? And I'll put that over 15. Okay. So when I do my cross products, I get 15x equals 81. I'll divide both sides by 15. And I get x is about, I think we get a funky number here, 5.4 for that. Okay. All right. For this particular one here, a little bit different. The lines are parallel, so they're allowing me to kind of take these sides and do, or sorry, this is a 4. Read. And I set it equal to the other side, the two segments that I got. Okay, so a little bit different here. I'll have to do some distribution there. So 12 times x is 12x. 12 times 4 is 48. And then 18x. Okay. I'm going to do this one a little bit different. I'm going to move the x's to the right-hand side by subtracting 12x. I get this. And I'll divide both sides by 6, and I get x is 8. Okay. So there you go. All right. I don't really like that problem because if you plug it back in, it doesn't make too much sense that those are going to be proportional, but they are taken by the rule. Okay. All right. Moving on. We have just some additions onto those two theorems that we had earlier, and this deals with the transversal. The other ones dealt with triangles. So transversals are just saying that when I have 2 or more or 3 or more parallel lines intersecting transversals, they divide the transversals proportionally. So it's just basically saying, here and here should be proportional to here and here. And that's the same rule we just had with the triangle. Okay. But this one's a little bit different. We got to make sure we kind of are careful on how we set this up. If I have a ray that bisects an angle of a triangle, okay, and let's not assume that's 90 either. What it's going to do is it's going to make the opposite side, or the side that it intersects, is going to cut that side into 2 segments. Okay, so it's pretty important to remember that. And it's going to be, I can take those 2 segments and make a ratio out of them. Okay, it doesn't matter how you set it up. If they did it that way, I could have had it flip. But I need to set it up with another ratio of the sides of the triangle, okay, that were not intersected. So it's important, if you notice this, that these 2 sides are adjacent to the 2 segments, okay? So we got to make sure that when we set that second one up, you got to get the adjacent sides to go with each other, okay? So really important word there that's not really in the corollary there, or the theorem. We got to make sure that we set that up properly, or we're going to be messed up. Okay. We're going to go here now to example 5 and find ST. So remember, if these lines are parallel, okay. So this segment and this segment, I could set up a proportion, and I could take the other 2 segments that are opposite it. Now I'll call this one X. That's ST. And I'll put that one over 11. So that's, we did that with a triangle, and this is kind of a triangle looking thing. It's just that they're transversals. So when you do your math, you get this. I'm going to go ahead and divide both sides by 9. And on this one, I get a fraction or a decimal that I don't really like. It's not really cool that you get a repeating decimal for a length of a segment, but if you do your math correctly, that's what you get. Okay. Coming down to this last one, this deals with that last theorem we just had, so we have to be careful. I've got this ray that's intersecting the opposite side and creating those segments. They want me to get AD, so I'm going to call that X. So I could take the X and I could put it over the other segment that's with that side and set it equal to their adjacent side. So the side that's adjacent to X is AC, which is 9. So they kind of have to go together here, okay? And then the other side, BC, is adjacent to BD, so we're going to use 15. Okay, so just really careful that you set that up properly. We're going to go here, we're going to get 15x. We're going to come here and get 90. And then I'll divide both sides by 15, and we get 6. Okay. All right, so this chapter really all kinds of proportions, setting stuff up, just making sure we identify things, looking for things that corresponding, and just being careful how we set up our proportions. All right. If you have any questions, please make sure that you email me, get a hold of me. We can work together a little bit that way, and then hopefully, do the classwork that goes with this, and get some good practice. Okay. All right. Thanks.